Hi guys, how are you? My greetings to all of you. I am Rishi Bhargava from Crack Academy. I am going to assist you all for quantitative aptitude. Me and my team are one of the best teams in India, and this series on aptitude lectures is going to be really awesome. So I'm going to describe the whole syllabi, which this syllabi is useful for which exams, and how you can conquer any aptitude or reasoning or paper which involves English as the section, right? So now, first of all, I am Rishi Bhargava. Me and my team of experts are going to teach this course to you, right? And this course is going to have quantitative aptitude, reasoning, data interpretation, and English. When we talk about English, every exam would have different type of English. So we are going to cater to each and every type of English solution. So what exactly do we have in quantitative aptitude? When I describe quantitative aptitude, now it can be broken into various parts. First is numbers. If you are appearing for any competitive exam like SSC, Bank PO, CDS, CSAT, Railways, nowadays a lot of questions would come from numbers. So what exactly are numbers? Classification of numbers, factors, divisibility rules, unit digit of a number, basic counting fundas, formulas. These are the major ingredients when we talk about numbers, right? So numbers are essential building part of quantitative aptitude. If you check out this year's CDS exam, you would realize that there were 8 to 9 questions from the same topic. So if you talk about CSAT 2023 CSAT, there were 19 questions from number system, right? So they define number system as general mental ability as well. General mental ability as well. Okay. So these are all the topics we are going to do with numbers. Then quantitative aptitude would have algebra. When I talk about algebra, right, I talk about arithmetic progression and geometric progression. There are a lot of questions which are very practical and can only be solved using arithmetic and geometric progression. So we have to do these topics. Then secondly, linear and quadratic equations. Again, if you talk about papers like CDS, you talk about SSC, you talk about banking, linear and quadratic equations actually come in each and every paper. Third, permutations and combinations. This has amazing weightage in a lot of papers. If you check out CSAT for past 5 years, they have been giving you a lot of questions from permutations and combinations. This is one topic which cannot be actually ignored. And probability. These are major ingredients of algebra, though there are other topics as well. When we talk about equations, it is not only quadratic equations, there are identities as well. So we have to talk about identities as a core topic for algebra. So now first part was numbers, second part is algebra, and then the third part, arithmetic. Arithmetic is a tool which is used daily to daily, isn't it? Day to day we use percentages, हम लोग use करते हैं, we use percentages, we use ratios. So when we talk about arithmetic, the core ingredients are percentages, ratios, and proportions, allegations, profit and loss, simple interest and compound interest, ages, partnerships, averages, right? And then, we are just forgetting time and work, time, work, time, distance, right? And various topics related to those topics. These are the major topics. There are a lot of subtopics as well. Arithmetic is very, very useful when you appear for CDS or SSC or Bank PO or CSAT, right? This course also caters to a lot of management exams, that is MAT, MAT, right? But again, if you are appearing for CAT or SAT, you require a level which is much, much higher than the teaching that we are going to impart over here. Okay. So then, sir, what is left? Geometry and mensuration. A core topic in exams like SSC, Bank, PO, CDS, railways, insurance, you name a paper, this course caters to each and every exam, right? When we talk about geometry and mensurations, yes, we talk about triangles, we talk about polygons, isn't it? We talk about quadrilaterals, right? We also talk about angles, right? We talk about lines, we talk about area, we talk about perimeters, volume, guys, and this is unbelievably high, surface areas. But the core part of geometry and mensuration, which one of my team is going to handle, would also be trigonometry. Trigonometry is one topic which is not very relevant in exam like CSAT, but if you appear for SSC, Bank PO, this is a real important topic. So we cannot define quantitative aptitude without this. Other than this, we are also going to talk about set theory, Venn diagrams, and quantitative reasoning. So fasten your seat belts. This is going to be amazing, right? We are going to talk about the exams for which this course is going to be very, very useful. First exam is SSC. Anyone who is preparing for SSC or Bank PO or CDS or any exam, state level exams like insurance, be it any entrance test, which actually, even PCS exams, state civil services examination, this course is going to cater to all these exams. State mein, you can talk about insurance as well. You can talk about railways as well. This course is going to be beneficial to all of you. Along with this course, we are going to provide you proper booklets. The booklets would be given to you in form of physical booklets. There would be a proper app support. So once you receive booklet, it doesn't end over there. After receiving booklet also, you would receive infinite number of assignments with solutions, with PYQs to cater to your needs, so that you are able to clear this exam very, very easily. So I hope that you have a proper distinction of what exactly this course caters to, right? And if you are preparing for, a lot of students would ask me, sir, which would be the toughest exam? In past 4-5 years, if you talk about aptitude and reasoning exam, I do cater to SSC also, Bank PO also, CDS also, but I find level of CSAT, that Civil Services Aptitude Test exam, is really, really awesome, right? So now, as far as my experience is concerned, I've been teaching students for this section, quantitative aptitude, for past 20 years, right? I am a grand old man, right? I have got a lot of experience. A lot of students have qualified for a lot of exams and they have cleared and they have become officers. And with pride, I can only say that you are with us and you are in the right hands when we talk about Crack Academy. Now, if you think of what exactly is Crack Academy, it's a one-stop solution. It's a one-stop solution for students, those who are in tier 3 and tier 4 cities. Students those who cannot move to bigger cities like Delhi, maybe Jaipur, maybe Chandigarh, maybe Lucknow, because of lack of resources, they cannot move. So Crack Academy is coming to these cities and Crack Academy is going to train you, and we all are qualified teachers and we all are going to make sure that all of you get results, right? So when we talk about Crack Academy, crack any exam with this academy. That is the basic motto of us, right? So I hope that I'm very clear. I have told you about myself, my team also, Mr. Karan Singh Katoch. He is one of the most renowned teachers around. Similarly, Mr. Sunil Kumar, he is one of the best teachers for SSC and Bank PO, right? So you have people, those who are actually good. The English section is taken care by Miss Ekta Batra. She is a very, very renowned faculty. For GS portion, we have accommodated best teachers from India. The recorded videos are going to be given to you. The notes are amazing. We are a 17-year-old company and we have made thousands of aspirants into officers like IAS, IPS officers. So you are in the right hands, right? So now I would start with number system. The core problem is all of us lack very simple basics. What exactly is number system and how do we connect number system with various other topics, right? So we have to talk about this, right? So first ingredient of number system, first classification is natural numbers. So guys, what are natural numbers? Whenever I ask students, they say, sir, 1 to infinity. Now, when we talk about 1 to infinity, right, this is actually wrong. See, 1 to infinity is all numbers, right? Now, understand, we as humans, we were also, why do we call animals and animals? We were also animals. So, somehow we are able to, collect ourselves, use our brain and, settle down. So, once we settle down, so let us make it as a history. Okay? So, suppose, humans started settling down near rivers, near, plains, and they started settling down. So they needed certain tools. So obviously first tool was counting tool. So when I say I have 4 horses, I have 6 cows. So see, there has to be a basic counting. So natural numbers is not 1 to infinity. See, 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, and even I should write 10, 11, and till infinity. This is a set of natural numbers starting with 1, all counting numbers. Now, all of you should understand these are called curly brackets. Curly brackets will always represent a set. What is a set? Set is a collection of elements. Okay. So curly brackets would represent a set. So you cannot say natural numbers is this set. These are your open brackets. Okay, whenever we talk about set, so these are the individual elements, right? So individual elements are actually written in a set. All right. So nothing other than the elements written. When I talk about 1 to infinity, open bracket, see this. So this is 1. So now he's saying all numbers from 1 to infinity. But over here in natural numbers, only counting numbers, which means, now here is the difference, no fractions, no decimals, no fractions, no decimals. That was the basic meaning of a set. Samjhe? So abhi you understand that 1 to infinity cannot be a set of natural numbers because it will involve all the numbers, infinite number of numbers, even fractions, decimals, everything. That is the reason we say this is not a set of natural number, this is a set of natural numbers. So first important part, and you should agree to this, many students did not know about this. Okay, 1 to infinity aise nahi hai, it is basic counting of the numbers. I have got 10 horses, I've got 15 cows, I've got 50 sheep. So understand this, right? So you may write it properly, please. All right. So after natural numbers, what do we require? See, it's more of a requirement. So second comes out to be whole number. Now, we required counting. Now, what do we require? Sir, we require 0, right? So, what are whole numbers? In natural numbers, you add one more element, 0, you get natural number. 0. 0 was invented by an Indian scientist, right? Named Aryabhatta. Indian mathematician, right? Named Aryabhatta. What does 0 represent? 0 represents nothing, isn't it? So I had 10 horses. Flood came and all the horses were swept away. How many horses are left? 0. So natural number did not have a representation of nothing. So then came 0. Aryabhatta invented it. It represents nothing, and nothing is as important. And many of us have been called zeros in our life. All of you would agree to it. Many a times our very close people would call us a zero because we had made silly mistakes. Maybe we were not able to generate good marks, or maybe we were not able to do something as expected, and we are called you're a zero, isn't it? But 0 is amazing, guys. Write down this whole numbers. So can I say whole numbers basically is natural numbers plus one more element, which is, now when I say 0 is amazing, a lot of you would be amused. So I'll talk about 0. First important part of 0. 0 is neither positive nor negative. Yes, 0 has no sign. That's brilliant, right? So please do not treat it as a positive number. Please do not treat it as a negative number. There are three categories of numbers: positive, negative, and neither positive nor negative, which is 0, right? Second, 0 is neither even nor odd. Many of maths background student would actually treat 0 as a even number, but from today onwards, just keep this thing in mind that 0 is neither even nor odd, because even and odd numbers, are classification of natural numbers. Even odd are classification of natural numbers, not integers. So negative numbers जो है -2 is not a even number, it's a negative number. ठीक है कि नहीं? Even odd हमेशा even odd are always considered to be for natural numbers, and that is the reason 0, क्योंकि 0 is not a natural number, so we would say 0 does not stand for even or odd, isn't it? Clear? Right? So see, now we are able to understand the number system that we talk about basically comes from the necessity, isn't it? We required it. Then let's do more properties of 0, guys. Are there any other properties of 0? 0 is a multiple of every number. 0 is a multiple of every number. Sir, how is it? Sir, how is 0 a multiple of 13? 0 can be written as 13 into 0. 0 can be written as 7 into 0. 0 can be written as 93 into 0. So 0 is a multiple of 13 as well, 7 as well, 93 as well. So 0 is a multiple of every number, guys. This is really, really important. समझे? ठीक है? Then fourth, 0 does not divide any number. The number that was created by Aryabhatta does not divide any number, right? Most of us know any number upon 0 is infinity, which basically we have done when we were in junior classes. But frankly telling you, it has nothing to do with infinity. It's called indeterminate, right? Cannot be determined. So keep this thing in mind that we don't say it. Now you're grown up enough to understand 0 has nothing to do with something upon 0 is infinity. That was when we were in school. It is indeterminate, cannot be determined. Now you tell me, don't you think 0 is amazing? Most of you want more zeros in your salaries. You don't want more 9s in your salary. You want more zeros in your salary. Why is it so? Because now, see, 0 is neither positive nor negative. So I can say 0 is God. Oh my God, right? Why? 0 is neither positive nor negative, which means 0 is, God. 0 is God. Why? God is neither black nor white. Agreed? God is, 0 is neither even nor odd. God is neither male nor female. 0 is a multiple of every number. God lies in all of us. God exists in all of us, like 0 is a multiple of every number. God lies within us, and 0 does not divide is same as, guys, God also does not divide us. From today onwards, 0 means a hero. Kindly make a note of it, please. Kindly make a note of this. So I hope now this is coming out to be really, really interesting. So then see, listen, as we started settling down, a lot of vices came into our mind, isn't it? So negativity. Negativity, isn't it? So negativity has to be defined by a negative number. So what do we require now? We require integers. We require integers. So what are integers, right? So listen, whole numbers plus negative images are your integers. So or best way, natural plus element 0 plus negative images of natural numbers would come out to be integers, right? For example, I want to write a set of integers, again curly brackets, minus infinity to minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, and so on till infinity. See this? This is a set of natural numbers, isn't it? Here lies 0, and these are negatives of natural numbers. Got it? These are integers. When we started settling down, negative were used. Why? I had 3 sheep. I went and I bet 5 sheep and I lost that bet. So how many sheep do I have? I gave 3 sheep, but I am still, having, I need to have 2 more sheep. So I am in negative. So it's like minus 2 sheep are left, isn't it? So that is where negatives come into play, right? So this is for integers. Kindly make a note of this, please. Come on, guys. Then, so first 3 cases, you should always keep this thing in mind. For natural, whole is natural plus 0. Integers are natural plus 0 plus negative of naturals, isn't it? For first 3 cases, no fractions, no decimals. It's really important. It's really important. First 3 cases, there are no fractions, no decimals. Naturals do not have any fractions. 3 by 2 is not a natural number, right? Whole do not have any fractions, right? And integers do not have any fractions, which means minus of 5 upon 3 is not an integer. Got it? If you get this, I think most of the basic would actually be clear, because a lot of people struggle with the same kind of basic, and you as a student, if you are sitting in a classroom, you would also understand the yes, Rishi sir is right on this part. By the way, I'm a core mathematician, MSc Maths, MPhil Maths, MBA in Marketing, so I have got keen interest in numbers, right? Shari, next time. Next, now what do we require? Again, as we started settling down, we grew up in population. As we started growing up, we needed things which we needed to divide things. Suppose someone had 4 sons and he had a piece of land. Now it has to be equally divided among 4 children. Division requires fractions. So this is where introduction of rational numbers come into play. Rational numbers. Can you make a note? What are rational numbers, guys? Rational numbers are numbers of the form p upon q, where q is not equal to 0, where p and q belongs to integer, and HCF of p and q is 1. HCF of p and q is 1. Kindly write down the whole definition. Kindly write down the whole definition. Every part is having certain meaning, and we generally, most of the students, if I ask what are rational numbers, the numbers of the form P upon Q. Arey nahin, this is not like that. You cannot directly say it, isn't it? You have to write certain things. Now, first thing that is being written is Q not equal to 0. Why? Because anything divided by 0 is indeterminate. Indeterminate. P and Q belong to integers. Why? Because fractions can be negative as well. It's not that fractions are positive only. So definitely numerator and denominator should belong to integer rather than to natural numbers, isn't it? Because fractions can also be negative, है ना? And then HCF of P and Q is 1. This is something I think most of us know it in our subconscious mind. What do I mean by this? देखो यार, once you were solving, when you were young, you were solving questions. When your answer came out to be 15 by 25, did you not cancel off the common factor and write 3 by 5? You keep on cancelling the common factors till there is no common factor, right? When we say HCF of P and Q is 1, we can also say P and Q are co-prime numbers. P and Q are co-prime numbers, right? This is really important. What is the meaning of co-prime numbers? Two numbers are said to be co-prime when their highest common factor is 1. एक बार note कर लो इसको, right? Why should they be co-prime? And secondly, a lot of students would ask you, sir, this means that 20 by 30 is not a rational number. No, it's not a rational number. Cancel off 10 from numerator and denominator. 2 by 3 is a rational number. Okay? Till the time you do not cancel off common factors, it is not a rational number. इसको आप लिख लीजिए. Kindly write it. Now, once you get with this definition, which obviously means now we are involving fractions. But what about integers? So my question to all of you would be, is every integer? Just a minute. Is every integer a rational number, or every rational is an integer? This question would shape up everything in number system. So kindly just check it out. Just check it out. बताओ. I think if you pick up an integer, देखो, if you pick up any integer, so I say 3 is an integer. 3 can be written as 3 upon 1, comes in the form of P upon Q. Pick up any more integer, minus 17. Minus 17 would be written as minus 17 upon 1. Again, it is of the form of P upon Q. So, and if we talk about rational numbers now involve fractions, and integers do not have any fractions. So it is not possible that every rational is an integer. The other way around it is possible. Every integer, write down, every integer is rational. And this is one question literally 50% of the students would not be able to answer this question. Every integer is rational, and vice versa is not always true. Vice versa is not always true. So I hope that now we are capable enough to understand what are rational numbers. Basically numbers involving fractions as well. Agreed. So then, is there any other category? Then came Irrational numbers. Irrational numbers. So when we talk about irrational numbers, a lot of students ask, sir, if you're good in English, you should understand irrational means not reasonable, right? But in mathematics, irrational would mean numbers that are not rational. So one definition is numbers that are not rational are irrational. Numbers that are not rational are irrational. Okay. Then the second definition is real numbers that are not rational. Again, yes, meaning wise, I think we are understanding the meaning, but a lot of students do not exactly know what are irrational numbers. Third definition is numbers that cannot be put in terms of P upon Q, where P and Q are integers and HCF and P on Q is 1, right? So these are the three definitions that I have always seen, and I wonder that most of us do not know the exact meaning of irrational after that also, because we don't have clarity. And then we have examples. Pi is 22/7, which is an approximate value. Anywhere you see pi, they would always write approximate value 22/7. Exact value of pi is not known. So now, so basically I want to say is that irrational numbers are numbers whose exact value is not known. I think does make some sense, isn't it? And then, numbers that cannot be put in terms of P upon Q. Let's see this. Suppose you know the examples, isn't it? This is 22/7 approximate, so don't bother. Okay? Don't tell me that, sir, why are you putting it? Anyhow, area of a circle is pi r square, but from today onwards, remember, there is always an error because pi is taken as approximately 22/7. Got it? And similarly, for example, everyone knows root of 3 is a irrational number. So most of the students tell me, sir, see this root of 3 upon 1, we can put root of 3 in terms of P upon Q. But what was the definition? Definition was, see, rational number definition was where P and Q belongs to integers. Either root of 3 is not an integer. Everyone knows it is a fraction. So this is something you should understand, that root of 3 is an irrational number, though root of 3 can be written as root of 3 upon 1, because root of 3 itself is not an integer. So sir, what shall we do? Right? Yeah, there is always a concept where say, sir, abhi kya karna hai? So I'll give you a very beautiful aspect of it. Irrational numbers are decimals that are non-terminating and non-recurring. They are decimals that are non-terminating and non-recurring. Non-terminating means जो कभी खत्म ना हो, something that does not dies, does not finish. Terminator, I'll end everyone. Non-terminating, that does not end. And non-repeating does not have a recurring pattern, isn't it? Does not have a repeating pattern. For example, if I write a number like this, 0.4173211930007891156327, right? 119998887326, and goes on like this. goes on like this. Now if I've written this number exists. If this number exists, this is your irrational number. This is your irrational number. If you check out root of 2, value of root of 2, you would understand it. Root of 2 in calculator 1.414, something like this. And there is a symbol E at the end of the calculator. Why? Goes till infinity. Is there any regular pattern of recurrence? No, sir, there is no regular pattern of recurrence. So what are the numbers which have regular pattern of recurrence? We will talk about this as well. For example, देखो यार, see this. I say what is 0.374 bar. Now a number with a bar would be 0.374, 74, 74, 74, 74, 74 till infinity. Now this number is non-terminating, going till infinity. It is non-terminating, but it is recurring. It is recurring, or I can say repeating as well. Okay, so see this 74, 74, 74, 74, 74, 74. This goes on till infinity. So this is non-terminating but recurring. So I would say this is not irrational. Not irrational. So if it is not irrational, what would be this number? So from today onwards, you should also keep in mind numbers with bar are always rational numbers. Numbers with bars are always rational numbers, right? So today you got to know what are irrational numbers in terms of if you want to write it. It's your own choice, write anything, right? 1.3879115600078198134576 and goes on like this is your irrational number. So you can write infinite numbers like that. So set of irrational number is always infinite. Okay, so don't ignore irrational numbers. Samjha? So now once we know irrational, we know rational. Now comes the most important numbers, which are called real numbers. Real numbers, right? What are real numbers? Real numbers minus infinity to infinity. Everything, all numbers. All numbers. Now see, these are your open brackets, right? These are your open brackets. These are not curly brackets, which means it includes everything. There is no end to it because infinity otherwise also does not end here. All numbers, right? Or the most important definition would actually be rational plus irrational. Rational plus irrational. Or we say all numbers on the number line. All numbers on the number line. So if you draw a number line, this is your 0. See, even 0 is so important. When we draw a number line, सबसे पहले हम लोग क्या? We draw zeros. The most important part. And this is minus infinity. This is plus infinity. So every number over here. Oh my God, infinite numbers, isn't it? I cannot even mark it either. These are your real numbers. Okay, so kindly mark it. Important hai, really important. And then after real, we do talk about complex numbers. We do talk about complex numbers. Numbers of the form a plus iota b, where a and b belong to real. and iota is under root of -1. Iota is under root of -1. So these are also called imaginary number because under root of -1 is not possible, isn't it? Under root of -1 is not possible. Any number, every real number is complex number. So how is this possible? 3 can be written as 3 plus iota times 0, isn't it? 3 plus iota times 0. But complex numbers do not exist. This is more of if we want to do complex geometry, which is a very useful tool when we are doing integration or higher mathematics. But you should write it, ठीक है ना? And also remember iota square is minus of 1. It is useful, right? Iota is useful. So what exactly is iota? Iota exactly is solution of the equation x square plus 1 is equal to 0. You should understand this. Sir, how is it possible? X square plus 1 is equal to 0. If you take any number, square of any number is positive. Positive plus 1 is equal to 0 is not possible, isn't it? So this equation does not have any solution, does not have any real solution till the time you introduce something called complex numbers. This would give you x square is equal to minus of 1, which means x is equal to under root of minus of 1, which means x is equal to iota. So I say, what is iota? Iota is a solution of equation x square plus 1 is equal to 0, though you don't need to get into it, but yes, we need to talk about it. All right. So every real number is a complex number is again something that you should make a note of. Hai? So if you are done with this, if you have made a note of this, then I'm going to proceed further. Yes, sir. So then comes a diagram. This is something called number system diagram. Number system diagram. If this is a set of natural numbers, you add 0, you get whole numbers. See this? What are whole numbers? 0 plus natural numbers, right? Then you add negative naturals, you get integers. So natural are contained in whole, whole are contained in integers, and we discussed every integer is a rational number. Q stands for rational number, right? And irrational number are totally different. Once you add rational plus irrational, you get real. So this is the exact diagram of a number system that you should have in your mind once you are doing numbers. Though I am going to add one more component, which is exactly if you say I don't think it is required, but then also you should understand it. And every real number is a complex number. So complex number come out to be containing everything. All right. So if you are good at this diagram, you can check a booklet also. Our booklet would also have this diagram. You are good at number system. But again, you know, one question that would be in your mind right now as well would actually be, sir, what about numbers with bars? Am I right? Numbers with bars. I said, see this. I am going back. I said this is a rational number. If this is a rational number, it has to be put in terms of P upon Q. It has to be put in terms of P upon Q. Every rational number can be put in terms of P upon Q. So how do you do that? 0.374 bar. Many times in a lot of exams, this yes, CSAT. In CSAT, I've seen this question 3-4 times. Right? In SSC, I've seen this question in combination with permutations and combinations. Right? So 0.34 bar. So first is this trick: how to convert a number with bar into P upon Q. So write down the whole number 374. Write down the whole number minus the number which is not having bar on it, minus 3, 374 minus 3 upon as many 9s for as many numbers having bar. So there are two numbers having bar, so you would have 2 9s. As many 9s as many numbers are under the bar, right? And 0 for numbers not under the bar. So 3 is not under the bar. For that you put 0. So your answer is 371 upon 990. If you check it in your calculator, you would get the same answer. So kindly make a note of this. Sir, one more example. You can think of 928 bar, 0.198 bar. Again same thing. Write down the whole number 198 minus the number which does not have bar, minus 1, upon as many 9s as many numbers having bars, 99, 0 for as many numbers having no bar, 197 upon 990, 197 upon 990. Clear? Sir, more examples? Yes, we should do more examples. If I say 0.197 bar, so bar is only on 7. Bar is only on 7, which is now equal to 197. 197. See the whole number minus the number having no bar, minus 19. See this? 19 is having no bar, right? Upon as many 9s as numbers under the bar, so there is only one number, so 19. As many zeros as no bars, 900. So it is going to be, see, 197 minus 20 is 177 plus 1, 178 upon 900. If you check out on your calculator, let me check out on my calculator as well. I just for your confirmation, I am getting this answer right. 178 divided by 900. Yes, I'm getting it right. I'm getting the same thing. 1.197 bar. This is what I'm getting in my calculator. So I hope you get the trick, right? For example, in UPSC CSAT they asked put 1.23 bar in terms of P upon Q. Now my method was working upon 0 point something. This is 1 point something, right? So this is going to be 1 plus 0.23 bar. So do not put the do not apply that trick till the time you have this format 0 point something. So remember, whenever you write a number like this 1.783 or maybe I'll give you 3.783, this is called integral part of the number, and this 0.783 is called fractional part of the number. Fractional part of the number, right? So once you get this number, put the fractional part out, right? Now this is what? See, this is 3 plus 0.783. This is fractional, this is integral. Once you separate it, now we can put that formula, which is the trick. 1 plus 23. See, 0.23. So 23 by 99 comes out to be 122 by 19. UPSC CSAT 2022, I think, right? So sir, how upon 99? Again, this would be bugging you. So let me see. I say what is 0.37 bar. So it is 37 upon how many 9s? As many numbers under the bar, 9. And how many zeros? There was no number without a bar, so there is no zero. So 37 bar is 37 upon 99. Kindly make a note of this. Now I hope you have got a basic clarity, na? So see this. What is 0.2 bar plus 0.3 bar plus 0.4 bar? It is 2 by 9 plus 3 by 9 plus 4 by 9, which is 9 by 9, which is equal to 1. So numbers with bar add up to give you a number which is an integer. So this is also true. Kindly make a note of this. So from today onwards, I hope none of my student is going to make a mistake. So sir, why? See, every trick has a reason, isn't it? Sir, why 0.374 bar comes out to be 371 upon 990? It might be coming in your mind. So देखो यार, yes, we have a trick now, but frankly, every trick has a reason, and I do believe that we should always talk about reasons rather than tricks. So the reason behind it, listen, I take x to be 0.374, x is equal to 0.374747474 till infinity. Right? Multiply this by 10. So 10x would be 3.74747474. So can I write it as 3.74 bar? If I multiply this number by 10. And similarly, if I multiply this number by 1000, you get 1000 x, which is equal to 374.7 bar. 374.7 bar. Right? So you name this as 1 and you name this as 2. Can you make a note of this, please, guys? This is important. If I say 2 minus 1, it would be 1000 times x minus 10x, isn't it? Which comes out to be 374.74 bar minus 3.74 bar, which means 990x. Now this 0.74 bar cancels out both sides. It comes out to be 374 minus 3, which means x would come out to be 371 upon 99. See, the same thing comes. So the trick is evolved from this logic. This is pure algebraic logic. Sir, one more time, right? For example, we had to do 0.37 bar. So I say it is 0.37, 37, 37, 37 till infinity. Let this be x. Let this be x. Right. If you multiply it by 100, 100 times x is equal to 37.37 bar. If you multiply by 1000, your 1000 x, right? So this is again very, very, very important, right? Whom to multiply, when to multiply is again a necessary thing to do, isn't it? So see, if you multiply, see, your answer has to come out to be 37 by 99, isn't it? So don't multiply by anything, just multiply by 100. 100 times x comes out to be 37.37 bar, and x was 0.37 bar, isn't it? So only 100 was required, 1000 was not required. If you minus these two, 99 times x again is 37.37 bar minus 0.37 bar. So which means 99 times x is equal to 37, because that bar wala portion gets cancelled out. So your x comes out to be 37 by 99. See how easily it can be sorted out. So this is a way with which we solve this problem. So I hope, guys, today was a good session on number system. Everyone has understood numbers as a whole, and we are going to do the next topic. So your next topic is going to be prime numbers. and factors and composite numbers. Till that time, I hope you have a good time. See you next time. I hope you are having a great time. Thank you so much. Jai Hind to all.